In this video, we're going to talk about how to construct a Pareto chart and bar graph. We have two examples to go through. First one deals with the number of intercity passengers in millions traveling by bus, air, subway, and Amtrak in 1995. And the data is listed in the table. So for bus transportation, we have 259 passengers. Air travel is 387.1. Subway 451.6, and Amtrak 29.7. So you'll notice that the information in the table tells us the class, which is the type of transportation, and the frequency, the number of passengers. We have a total of 1,127.4 passengers. Now you're wondering, how do I have 0.4 of a passenger maybe? So these are the average number of passengers. So that's how we can get into decimal values. So what we want to look at first of all for part A is to calculate the proportion of passengers for each type of transportation. So we will take the bus travelers of 259 and divide that by the total, 1,127.4, and that equals 0.2297. Next, we'll have our air travelers, and that's 387.1 divided by the total, and that brings us to 0.3434. Next is the subway. We have 451.6 divided by the total, and that gives us 0.4006. Last, we have Amtrak, 29.7 divided by the total, and that gives us 0.0263. So you'll notice that since I worked on a keyboard, it automatically went to 4 decimal places. So we may want to go back and talk about rounding. I think that I'll go to the nearest hundredth. So 0.2297 would become 0.23. Next we have 0.3434, that would round to 0.34. Next, 0.4006 would round as 0.40. And last, we would have 0.0263 rounding to 0.03. So I've just taken what a calculator or any kind of spreadsheet might automatically round and declare hundredths as our final decimal placement. So for part A, we calculated the proportion of passengers for each type of transportation. Now that we have found the proportion of passengers for each type of transportation, we want to verify that those proportions add to 1. So I'm going to take my rounded decimals, 0.23, add it to 0.34, add 0.4, finally add 0.03, and you can see that that does in fact add to 1. 1 is the largest relative frequency that we can have because 1 represents 100% of the data. Finally, for part C, we're going to use the results from part B, that is, we're going to use our relative frequency values and create a Pareto chart for the different types of transportation. So with the Pareto chart, you may recall that it can be a bar graph, but what's special about this bar graph is that the bars will be drawn in descending order. So I'll draw my vertical and horizontal axes. We have relative frequency for the vertical axis, and our horizontal axis is going to be the type of transportation. So looking back to our relative frequencies, I can see that 0.4 is the largest relative frequency, so subway should be my first category. My second highest value is 0.34 for air. The third highest is bus, and last is Amtrak. So now I'll place the scale on the relative frequency axis. Now that I have my scale, I can draw the bars that represent riders of the subway, air, bus, and Amtrak. So for subway, I've got 0.4. For air, the bar goes to 0.34. For bus, 0.23. And finally, Amtrak at 0.03. And as you can see, The tallest bar is on the left, and the bars are in descending order. So there's my Pareto chart. Now what's missing is a title, Relative Frequency of Inner-City Passenger Travel. And we should also label our horizontal axis as modes of transportation. So we now have a complete Pareto chart. So for number 3, law, corporation lawsuits. Many people say the civil justice system is overburdened. Many cases center on lawsuits involving businesses. Researchers conducted a study of lawsuits involving 1,908 businesses ranked in the Fortune 1000 over a 20-year period. Construct and interpret a graph that will aid researchers in understanding the distribution of civil justice caseloads brought before the federal courts involving the businesses. So our table indicates the case type and number of filings. Since number of filings is frequency, we'll create a frequency bar graph. So to create that, I need to draw a vertical and a horizontal axis. We have a vertical and horizontal axis created, and I will put titles. The title of the horizontal axis should be case type. The first case type is contracts, so I'm going to just put the bars on the bar graph according to what order they are written in the case type table. So we have contracts, general torts, asbestos liability, other product liability, and all other cases. The vertical axis will be labeled number of filings. So we'll need to choose an appropriate scale, and that will be determined by the actual numbers here in our table. Our smallest value is 27, and the largest value is 186. So we could probably count by 25. So when I'm making these tick marks, I need to try my best to space them evenly so that I won't have any distortion when I'm actually drawing the bars. So since this is a frequency, I don't need any decimals. My count is by 25s. So I could write every number in, or just some of them, as long as I know what the scale is. So now I can go back to the table, contracts, the bar should go up to 115, so that would be slightly past 100. General torts, 186 would be just past the 175. Asbestos liability at 53, so just above 50. Other product liability, 42. And finally, all other at 27. So here we have our bar graph. The vertical axis represents the number of filings, horizontal axis, the case types. So a good title for this graph might be Frequency of Lawsuits. And then we have our complete graph. So what's left is the interpretation of this graph. What our eye tends to notice is the highest bar, or if several bars are of the same height, any kind of trend that's going on in the picture. So it's easy to see that this is the highest bar, that's related to general torts. So you might write something to the effect of the most frequent type of corporation lawsuit is general torts, which occur 44% of the time. And there's our bar graph.